I'm Ram Mathia. I work at Google on Cuttlefish, which is an Android virtual device, and also generic bootloaders. I'm going to talk about both of those back to back. Yeah, so guess let's get into it. So first, a brief primer on what is Cuttlefish. It's an Android virtual device. It's been around since about Android O, which is coming up on 7 or 8 years now. It's been used primarily by kernel developers, BSP developers, systems developers in the ecosystem to help develop pre-silicon hardware, kernel changes, HALs, and the various different Android configs you see around. So tablets, there's a laptop one, phones, Wear devices now, etc. So, yeah. As for why you should use it, I'm going to spend a bit of time here. It's VirtIO compliant. It's been that way from the start, and we've supported a whole bunch of devices. Notably, GPU finally landed for ARM64 earlier this year, Sound maybe 2 years ago, input devices, net, Wi-Fi block, etc. As for the VMMs we support, QEMU is beneficial for most of the kernel developers and standard workflow. So we've supported that for a while. CrossVM is a Rust-based VMM that's homegrown at Google for enabling Android on Chrome OS. And we've started using that for maybe the last 5 for the folks who are doing more hardware level development or silicon development. And then QNX and Open Synergy for the automotive folks in the audience. That's been brought up by vendors who use those. We don't actually maintain those at Google. The various inputs and outputs to interact with the virtual device once you've got it started. ADB, obviously. There's serial in case the device has, host itself, and you can screen into that serial port if you'd like. WebRTC, just go to localhost 8443 HTTPS, and you'll be able to interact with the device. I'll show you what that looks like in another slide. Audio input and output will be there, so you can do like your whole hello Google or sideload whatever you'd want via ADB as well. A fun fact is we've been using it to test a large volume of the Android common kernel changes within Google for maybe 3 to 4 years now. And that's been running on CI/CD for that long. As for the targets we support, ARM64, x86-64, ARM32 and x86 are both slowly being turned down, hopefully by the end of this year, just as Android focuses on 64-bit only. And then RISC-V64 is, we do support booting that kernel configuration despite the Android police article that came out a few days ago. That's maintained by a different team at Google, but yeah, we do maintain it and it does work. Or at least the Cuttlefish port of it does work. As for the various vertical you can run Cuttlefish on, the 2 cloud providers of note that we at least have confirmation people use, GCP, what we use internally. We do have plenty of folks who use AWS for our ARM64 port with respect to their bare metal instances, with or without GPU. Ampere boxes if you want to set up your own local infra, which a number of folks have done. And then for single board computers, SBCs, RockPi, Raspberry Pi 5, and then you can emulate with QEMU on your standard machines. As for bootloaders, we added bootloader support about 4 years ago now, and we started with U-Boot, or specifically the Android fork of U-Boot, for a number of reasons. We were thinking about UEFI compat at that time, and it does bring that along. Within that bootloader fork we maintain, we have boot config and AVB support, which is also present on upstream. We did recently add fastboot support as well to Cuttlefish, so you can now fastboot reflash the device with whatever you want to test out various OTAs, and it's all upstream, so yeah. Getting started with development, it's a brief overview. There's a link at the end on how you would be able to do this a bit more in depth. If you're running Debian, just go to that GitHub link, build the packages, install them. As for the Android build, you'll want to build that x86-64 target or ARM64 target, just change the architecture type. And then if you would like to develop a kernel, that's the recipe for the Cuttlefish module set, and then the x86 port of GKI. We also support Android 15.6.6, which isn't listed here. So once you've built all three of those, installed the various dependencies, you should be able to launch the device with those kernels, with that kernel, or you can use the default one that's on the device if you'd like. Just drop those two parameters for kernel path and init ramfs path. And then, yeah, go to that WebRTC port, and you should be able to see that. You can check out the dmessage if you'd like, ADBN, fastboot as well. We also recently revived a bit-rotted GDB support for this, so instructions for that will be on our sourceandroid.com page, which I'll link at the end, so if you'd like to GDB with it. We do support GDB for both the bootloader and the kernel. Paul over in the audience worked on that, so thanks to Paul for that. As for things we're looking at next, so I'll cover EFI boot in the next presentation, or in the next set of slides. If you would like to, we currently do have a proof of concept running with EFI. We would also, for all the automotive interest, like to support VirtIOS CMI, along with the other VirtIO specs that have come out. RPMB, GPIO, and then media acceleration. And if you would like to make feature requests, talk with me now, or at the end. Or you can just email us there if you'd like to discuss in a more private forum. And then that's the sourceandroid.com link for Cuttlefish. And yeah, cool. So I'll jump into the bootloader section, then we'll do questions at the end for back-to-back. So a typical Android bootloader is the final stage of the boot chain off of any generic XBL, as we'd call it, or extensible bootloader. It does a whole bunch of things, some of them common to all the vendors and some of them a bit more bespoke to each vendor. So brief listings on each side. It'll extract out the various boot images. We'll assemble them in memory, do AVB or Android verified boot. What do you call it? Do device lock state assessment. So, figuring out whether or not the device is locked or unlocked, and then canceling the boot if not. And then some things a bit more bespoke, hypervisor initialization, figuring out which slot to boot into based on whether previous boots have succeeded or failed, determining off of the hardware for random number generation, doing measured boot off of trust zone, and then also the display of the splash screen for boot. And so there's a number of issues and optimizations that could be observed. Every single vendor is redoing a lot of common logic that Google is specifying as how to boot Android. And then there are a few vendor differences that are all accomplishing the same thing, but are specific to vendor hardware. So there's an option there for putting an interface down and going and developing Google-related software off of those interfaces that might be standardized. And then also every single year, maybe for the last 3 or 4 years, Google has mandated changes to the boot requirements. Things like adding vendor boot when we released the generic kernel image to enable kernel modules from the vendor to be separated from the kernel image, init boot to hold init, and then the boot config to force user parameters or user space parameters in from the bootloader. Let's see. So every year that we've had to add these changes, the vendors have all had to correspondingly update their various bootloaders with these patches and leave behind older device trees, not device trees, but older stacks of firmware for older socks and devices. And then lastly, most people do not, or most vendors don't update their bootloaders just because it's so early in the boot chain, and vulnerabilities, if they're caught, aren't really going to be deployed to the factory and reprogrammed there, and you're not really going to get OTA. So if something serious enough was to be caught, yeah, it'd have to be backported to hundreds of device firmwares. So past solutions to this problem that you should pay homage to. Upstream U-Boot was, for Android, was developed quite considerably by Lenaro. I think Sam Pritsekko put a lot of work into that when he was working with TI. Android Things as well also spent a considerable amount of time when they brought this up on their U-Boot fork with respect to the Edison boards. And then EFI Droid was a Qualcomm-derived bootloader that supported all the Qualcomm SoCs and was open source. A number of those folks have gone on to Lineage OS at this point, I believe. And all of those attempted to have these Android boot changes upstream and maintained. Those projects have all stalled for various reasons. And so anyways, back to the problem statement that we've derived. If Google could provide a generic Android loader to the ecosystem that got updates every release, how might a vendor go about integrating it, extending it with their own specific use cases? A spec exists, UEFI. It's been around for a while. 2.1, it's not actually 10 years, that's 2. That's an error. A lot of bootloaders support it, with the notable exception of little kernel, and it supports discoverable calls, so you can probe for various bits that the firmware might support, and if they do support it, you would call into those. So the proposal, Google provides a generic Android bootloader application every release, which accommodates new boot requirements for that corresponding launch. It would get patches for security updates. It would be backwards compatible. So the intention would be to support, an Android 10 device with the latest bootloader. At a min, the protocols we need the vendor to implement in their bootloader if they wanted to use these are RNG, block IO, slot selection or slot discovery to figure out which boot slot to take, the Android verified boot key, and then link to source is at the end. And then more importantly, any requirements we haven't thought of. Some things have been pointed out to me. Obviously, we haven't touched on display yet. So code and the README are here. We have CI set up, which is testing the resulting builds on Cuttlefish, and the artifacts are available there. So what's next for this initiative? We'd like to get your feedback and incorporate that. We're looking into little kernel's UEFI support, so it doesn't have a UEFI loader, but the maintainer's been open to us adding it. So we'll start to look into that. And then comments, questions, you can email them to me if you'd like. That's my email. Thanks for your time. And we have 2 mics.
Hi, I'm Srivatsa from Qualcomm. If we are looking at options for a bootloader that can run in a VM context, not for the host, do you think this would be one of the choices we can evaluate, or?
Let me think about that. I don't see why not.
Primarily, we would want some device tree manipulation functions. We may not need a lot of the other features that you're targeting. Yeah. But we'll have a look, nevertheless.
Okay. I presume the calling firmware that would call this app is this at all related to the PVM project that's open source, or?
We have our own VMs. The first stage of the VM execution would be this proposed bootloader.
Okay. So in this case, this is just a boot application that would rely on a UEFI firmware.
So without the UFI, it will not.
Yeah, we would need to build on top of it.
So we need some thin UFI.
Yeah.
Okay.
So I'd like to ask about the relationship between cuttlefish and trout.
Mhm.
Because right now, if you want to build Android Automotive OS,
Mhm.
you have targets
Yep.
that will build using cuttlefish, other targets using trout.
Yep.
I've seen in one of the slides that cuttlefish is going to support Virtual CMI.
We're looking at supporting that along with the other things.
But the question is, sorry, the question is which one is going to be the main target for building Android Automotive OS?
At the moment, that is trout. That is trout. And if we were to add that, there's a delta between the two that I believe we're working on shrinking at this moment. I assume you've worked with Enrico at Google. Okay, I'm sorry, which is your, okay, you're at Red Hat, got it.
Yeah.
Okay, let me come back to you with that one.
Sure, thanks. Yeah, it's because looking at the changes in the code in Android, it seems like Cuttlefish is making more progress than Trout. So it's like we are not sure which one should be targeting right now.
So the intention is to eventually shift over, but I wouldn't like to make any promises right now.
Thank you.
Hi, Dan Handley, ARM. So the generic bootloader, I just wonder how production ready is it? Is it used in real devices? Yeah.
No. So we're targeting Android W, which is the Android release coming out end of October 26.
Okay.
We currently have support on a Vim 3L and a Cuttlefish, which is the Android virtual device.
Okay. So yeah, I mean, you know, we've done some downstream work in our reference platforms, you know, probably based on the upstream U-boot stuff. But this looks really interesting to sort of vect to at some point. I don't know if there's things like, you know, support for the PVM firmware and things like that. Is that coming or?
That's there is some interest in supporting that, but I don't have those plans concrete yet. What exactly would you be looking for on that?
Well, there's requirements in the boot firmware to load the PKVM firmware, which that's installed into the hypervisor.
So the current thought is, for the first pass, we would like to keep the focus relatively small, and we would leave as much trust zone TA related stuff to the firmware as possible, and just abstract away the boot, just Android boot.
All right, and sorry, just final question. The other big useful thing would be the, you know, a firmware update story. You know, as you observed, that's a really poor, missing a gap in the Android ecosystem, I think, for firmware updatability.
So currently we don't standardize how every vendor implements their AB slot. We have a reference implementation for this MISC partition thing. We would look at standardizing that for future updates to this. If you have any recommendations, I was talking with Ilias about a spec he has out.
Well, there's the ARM firmware update spec, which has an implementation of in U-boot, but you know, leveraging that would be ideal. Yeah.
We'll definitely look at that. Yeah.
Thanks.
Hi. Is the generic bootloader intended to be used on Google production devices like Pixel in the long term?
We are looking at bringing that up. We don't have any plans to land with Pixel yet, and I can't talk about the discussions yet. Yeah.
Are we planning on using our own emulator, on having this on our own emulator, Cuttlefish?
Yes. So that support does exist. It's, if you go to that link, there's a README under libbootloader GBL that describes how to launch.
Great, thanks.
Thank you.